Hello all, I am Dr. Prabhas Chananbal. In today's class, we'll discuss about the undecidability problem, decidability problem, and reduction problem. These are the very important problems. So first thing, before going to the undecidability, first we'll see what is the meaning of decidable problem. We have already discussed about decidability and undecidability problem in some previous classes like decidability and decision properties of regular language, decision properties of contestable language. In these classes, we have already discussed, but in these classes, and in the next two classes, we'll discuss in very detail what is the meaning of decidable problem and undecidable problem. Okay, see. So what is the meaning of decidable problem? A problem is said to be decidable problem. A problem is said to be decidable problem if there exists an algorithm. If there exists an algorithm to solve that problem, this problem is called as decidable problem. Okay. So a problem is said to be decidable problem if there exists an algorithm to solve that problem. This problem is called as decidable problem. Okay, now we'll see some examples of decidable problem. So see, these are the following examples. These are the following examples, or the following problems are called decidable problem. Okay, see, TSP means traveling salesman problem. Second one is called matrix multiplication problem, or if matrix multiplication problem is decidable, traveling salesman problem is decidable, sorting problem is decidable, searching problem is decidable. We can write capital D. See, okay. Capital D means this problem is called decidable problem. 01 knapsack, this problem is decidable. Why this problem is decidable? Because there exists an algorithm to solve that problem. TSP, for TSP problem is traveling salesman problem, there exists an algorithm. Matrix multiplication problem, there exists an algorithm. Sorting, there exists an algorithm. Searching, there exists an algorithm. 01 knapsack, there exists an algorithm. Okay, so that's why this problem is called as decidable problem. Okay, next we'll see about the undecidability problem. Okay, see the definition. The definition of undecidability problem. A problem is said to be undecidable problem. The problem is said to be undecidability problem or undecidable problem if there exists no algorithm, means there is no algorithm exists to solve that problem. If there exists no algorithm to solve the problem, this problem is called as undecidability problem. Undecidable problem means there is no algorithm exists to solve that problem. This problem is called as undecidable problem. Okay, now we'll see some examples of undecidable problem. Okay, see, the following are the undecidable problem. Okay, first undecidable problem is this one is undecidable. X to the power n plus y to the power n equals to z to the power n. X to the power n plus y to the power n equals to z to the power n. N is greater or equal to n. Sorry, 3. N is greater or equal to 3. That means if n value is less than 3, this problem is decidable. But for n value is greater or equal to 3, this problem is undecidable problem. Okay, the next problem is ambiguity problem is undecidable problem. Ambiguity because there is no algorithm to solve that problem. That's why this problem is called undecidable problem. The next problem, post correspondence problem. This post correspondence problem is called undecidable problem. The post correspondence problem is undecidable problem because there is no algorithm to solve that problem. Okay, these three problems, there exists no algorithm, or there is no algorithm exists to solve these three problems. Means x to the power n plus y to the power n equals to z to the power n, where n is greater or equals to 3, ambiguity problem, post correspondence problem. Okay, these problems are completely undecidable problem because there is no algorithm exists to solve that problem. Okay, in the next class we'll see about post correspondence problem and modified post correspondence problem. Okay, so next concept, this is very important concept, a reduction problem. So what is the meaning of reduction problem? A problem A is reduced to problem B. A problem A is reduced to B means we can write like this. A problem A is reduced to problem B. Here we can write like this. Problem A is reduced to problem B. Means what is the meaning of the reduction problem, or a problem A is reduced to B? We can conclude that the problem B, we can conclude that the problem B with the help of problem A. A problem A is reduced to problem B, that means the problem B with the help of problem A. This is called as the reduction problem. Very important problem. We'll use it, frequently used in some upcoming classes like or complexity problems like this. Okay, clear? A problem A is reduced to problem B means we can conclude that the problem B with the help of problem A. Okay, so try to understand what is the meaning. If A is reduced to B, this meaning is like that. If A is reduced to B, then the following are the possibilities for decidable and undecidable problem. Okay, so see, the first point, this part is left part is called A part, right part is called B part. Okay, if A is reduced to B, so that means if A is reduced to B, we can say that if A exists, if A is undecidable, then we can say that B is undecidable. In case of undecidability, if A is undecidable problem, then we can say that B is undecidable. But in case of decidable problem, if B is decidable, then we can say that A is decidable. Okay, that means for A case, this is B. For undecidability problem, if B is undecidable, sorry, if A is undecidable, we can say that B is undecidable. If A is undecidable, then we can say that B is undecidable. But in case of decidable problem, if B is decidable first, if B is decidable, we can say that A is decidable. This is very important problem. Okay, so if A is reduced to B, if A is reduced to B means, see, if A is reduced to B, if A is undecidable, then we can say that B is undecidable. If B is decidable, then we can say that A is decidable. Okay, so these are the mainly definitions of decidable problem, undecidable problem, and reduction problems. In the next classes, we'll see about some examples and some problems we'll see. Okay, first we'll solve some undecidable problems. Like in the next class, mainly we'll solve the first correspondence problem, and second one is the modified post correspondence problem. Okay, thanks for watching.